live.
Yay.
Here we go. This is it. Setting up your meeting on Facebook Live. All right. Countdown to ignition.
Yes.
In 5.
Count to lift off. I know. 4. I don't have the voice for it. John sounds better with the voice.
Love it. It's great. I think
I need to remember.
yeah, we're live.
Yay!
Hello, guys. We're live. Woo! Welcome to the Johnson City Public Library Space Talk. Joining us tonight, we have Amanda Mayo, who is a NASA Solar System Ambassador, and she is also from a geology background. And then we also have John Krekelberg joining us from our Johnson City's own area, hands-on Discovery Center. I guess it's technically gray.
Close enough.
Yeah, the area, Washington County area, and has a physics background. So I think the two of you will make outstanding experts to answer your questions. And they're also going to do some just wonderful visuals for you. So I'm so excited. I'm going to hand it over to Amanda. Get us going. Woohoo!
All right. So I want to give everybody a little bit of time to get on. I know my cousins from Georgia are so excited to join us tonight. And I just have a bunch of people that are going to be coming on. So I need to make sure we give them time to get on and get, the Facebook Live on and everything. But I do have a PowerPoint, so we can at least get that started.
Awesome.
Slideshow. So I don't know, can y'all see this?
Let's see it.
I see you. Do you see it, John?
I see it.
I see it on the Facebook page.
Yay, yes, yeah. I've got the Facebook pulled up on my phone so I can kind of, see who's watching, where we're watching from. So if you are joining us, make sure you give us a shout out. Tell us who you are in the comments. Tell us what you're interested in so we can make sure we're gearing it more towards you. Like if you are obsessed with the Kuiper Belt, let me know in the comments because I am too. And so I would love to hear from you. Let me know, what you think of this program because hopefully we can get more of these going in the future. And I'm so excited about that.
Awesome.
Yeah. So first of all, I would like to give a huge shout out to the Johnson City Public Library because this would not be possible without the help of Miss Lisa Krekelberg. I don't know if you guys know this, but we have been working on this program for months. We have been, with the whole COVID situation and everything that's been going on in the world, me and Miss Krekelberg have been working together to get this going and make sure that we can have an awesome program for you guys. And my dogs are excited about this program too. So I have 2 doggies in the background that are going to be joining us. And yeah, they're my cheer squad, I guess. So they're excited about space. So huge thank you to Miss Krekelberg because without her, this would not be possible. And I am so excited to bring you guys Space Talk.
Space Talk. I have a dog too. So if you hear barking, it could be me.
Yes. So first I'm going to tell you guys kind of what we're going to be doing this evening. First of all, we're going to talk about what exactly it means to be a NASA Solar System Ambassador because it is such a cool program. It is citizen science. It is NASA's boots on the ground for education. And I'll tell you all a little bit more about that here in a minute. I'm going to talk a little bit about myself and why I got into NASA Solar System Ambassadors and why I think space is so cool. And then we're going to talk about Mr. John Krekelberg, who he is dressed way cooler than I am, and I'm so jealous. And I think we're like best friends now. And then we're going to go over some questions and answers because you guys had some awesome questions and you had some awesome things that you wanted me to talk about today. And you added them on Facebook, you added them on Instagram, and I was so excited to see that y'all were excited. And then we're going to talk a little bit about aerodynamics because that's a really big, scary word, but I don't think it's scary. And I hope by the end of this presentation tonight, that you guys will be just as excited as I am about aerodynamics and the science of flight. After that, we are going to do a little origami activity. And I've got some space trivia. So a bunch of my NASA Solar System Ambassador friends, I asked them on Facebook today, I said, what is you guys' favorite piece of space trivia? So I have some awesome space trivia if we have time at the end. And if we have any final questions towards the end of this activity, we can, if you have any, let us know in the comments. And, we can answer them as we go if it, or we can save it to the end if it's a really cool question. And if it's a really cool topic, I think that we should do like a whole separate event for it later on because we just don't have enough time in an hour to do so many awesome things. So I'm so excited about that. And we have somebody that said on Facebook, hello, this is Jacob, Liam, Lee, and AC Mayo. Those are my cousins from Georgia. So we have people watching us from Georgia. So that's awesome. If you're watching and you think your friends would like to see us, make sure you're sharing, make sure you're liking, and we would love to see your comments. I would love to see who's watching and who I'm interacting with.
Absolutely. I love your slides here, Amanda. These are beautiful.
Thank you. All right, so first off, let's talk about what NASA Solar System Ambassadors do. What you do for NASA Solar System Ambassadors is, like I said, it's NASA's boots on the ground for education. And what I do with NASA Solar System Ambassadors is I do programs like this a lot. And the coolest thing about being a NASA Solar System Ambassador is that we get like a really cool official looking NASA name tag. So I am so excited about that. I'll tell you a little bit about me later, but I do beauty pageants, and I thought it was so funny. I used my pageant headshot for my NASA name badge. So if you ever want to talk about like somebody doing a lot of things, that's me. So I get this really cool name badge, and we do a lot of programming like this. And we also get to do a lot of training from NASA. So through the NASA Solar System Ambassadors program, I have gotten to interact and talk with, like, there was one lady that we got to talk to. Her name was Miss Bean, or Carrie Bean, or actually Dr. Carrie Bean. And she's actually on Instagram. She helps drive the Mars rovers. So she sits here on Earth and does the toggle to drive the Mars rover on Mars. And I got to talk to her, interact with her in a Zoom meeting just like this. And I thought that was so cool, because when else are you ever going to get to like be like, I've spoken to a Mars rover driver. And I actually had the opportunity. I was doing a research project for my structural geology class, and I actually emailed her with a question about my research that I was working on. It was on the Tharsis region of Mars. And she actually emailed me back. So I got to cite a NASA Mars rover scientist in my research paper for college. So that was super cool. And NASA does a lot of other things. I'll show you guys, our NASA Solar System Ambassadors do a lot of other things. We get all kinds of educational materials that we can take to students. And I was just telling Ms. Krekelberg, I will try to get some of these mailed to the Johnson City Public Library. I actually live in Martin, Tennessee. So maybe a little bit before they get there, but these should be available for drop off or for the pickup, first come, first serve. I'll send a couple. But we get all kinds of cool NASA fact sheets. And one of my favorite things that I've got right now that I'm going to send to the Johnson City Public Library is a Mars Perseverance poster. So it's got the Mars 2020 on it. And I'm going to tell y'all a little bit about the Perseverance rover and what the objectives are, because I absolutely love Mars. It's my favorite planet. So that's a question that I get a lot, is what is my favorite planet? And it's Mars, because it is just so cool. So I've got these really awesome posters that I'll be sending your way.
Maybe comment below if you have a family member, or if you really would like some of this material, because we could, like I said, like Amanda said, there's going to be a limited amount, but we could always
for sure
for you curbside. So make a comment if you want, and we can do that.
Yes. So I'm so excited about that. Yeah, so I'll be getting those to the Johnson City Public Library. And I've got some stickers too. So if you love stickers, like I like to put them on my laptop, I'll be sending some stickers too. So that's a little bit about the NASA Solar System Ambassadors Program. Now a little bit about me, like why is this lady talking about space to me? So my name is Amanda Mayo. I just graduated with a degree in geology from the University of Tennessee at Martin. And geology is the study of rocks. Well, what does that have to do with space? Space is rocks. Space is all of these rocks that are flying through space. We have asteroids. We have all kinds of things that have to do with geology in space. So being a geologist, yes, we can study things here on the ground, but we also need to study the geology of planets and stuff. So we call that exogeology, or sometimes planetary geology, and some people call it astrogeology. So what I do is we can look at the structures, we can look at the processes that are happening here on Earth, and we can actually say, that looks really similar to what's happening on the moon or what's happening on Mars. And we can relate those processes, and we can relate those things that are happening here on Earth to things that are happening on other planets. So geology and astronomy work really, really well together. So that's a little bit about me. I also said I do beauty pageants. So yes, I am the reigning Miss Shelby County 2020 and 2021. So what I do with that is my personal platform is Stand for STEM or Project STEAM, promoting earth science in the classroom. So I go to classrooms and I get to wear my cool little NASA name badge, and I get to talk about space and I get to talk about geology, because with any other science, anything that we understand here on Earth, we have to start at the ground level, and the ground level is geology. So that's why learning geology and learning earth science is so important. I have a professor that jokes that he can relate anything on Earth to geology. And he does. Like the glasses on your face, geology. The water you're drinking, geology. Everything, he can relate it to geology. So it's super important. So, and now I would love to introduce Mr. John Krekelberg, who was so nice to join us for this presentation. Would you like to talk about yourself for a minute?
Oh, I'd love to talk about myself for a couple minutes. My name is John Krekelberg. I work at the Hands-On Discovery Center in Gray, Tennessee, just outside, like a couple minutes up the road from Johnson City. But it took a long road to get to here. I actually was born in Minnesota, and my family relocated to Tennessee when I was like on my 5th birthday. Actually grew up here, volunteered at the library when I was in middle school and high school. So yay library, and went to college in Greenville, Furman University, where I graduated with a degree in physics, general physics. But I really had a passion for astronomy, for space science, and I even had to pressure the physics department to offer physics courses because I'd exhausted the entire roster of classes by my senior year. After graduating, I actually relocated to Southern California, where I taught at an outdoor education camp. It's called Astro Camp, where we taught children from 5 to 8th grade all these awesome interactive science courses with everything from atmosphere and gases to lights and lasers, things all around us in our universe that we can study here on Earth, but are very translatable to space science. So it was a general physics camp with a emphasis on space science. And every night we went out to the telescopes and did a space night, a star party. It was a really awesome experience. I was out there for about 4 years before I relocated back to Northeast Tennessee and actually started work at Hands-On when it was Hands-On Regional Museum. That was a couple years ago. Since then, we've kind of grown up to become the Discovery Center out here in Gray, where we are an all ages science facility. And I am one of the program coordinators who actually interacts with guests and does outreaches. And in the year 2020, I started becoming a YouTuber so we could actually reach out to people at home and bring some science into the classrooms at home. So right now I do work at Hands-On, but before I got here, about the 1st or 2nd year that I started working here, Astro Camp actually reached out to me and said, "Hey, John, you want to still teach some science with us?" And I said, "Yeah, how do I do that?" They said, "We're going to China." So we actually went to China for the summer, where we actually pioneered a new Astro Camp remote learning center in Bagaihe district out in China. So that was a really awesome and eye-opening experience for me too, because it's not just, us here in the United States who are interested in the science of space. Because we are all one global community, you're all looking up at the stars with the same wonder and amazement and ask the same questions. So I guess in a nutshell, that's me. I'm a science nerd who really loves space, and I love talking about it. And if I get too long-winded, just shut me down. Just cut me off. But back to you, Amanda.
Thank you. I know John and I were talking before this program started. We were getting our Zoom meeting together, and I said, well, I made us a PowerPoint that has a list of what we're going to talk about because I get way too excited about everything. So I made us a PowerPoint, and if I get off topic, I'm going to bring myself back around.
You guys are both, I'm just in awe of both of you. You're amazing, and we are so excited to have you all here. And we're so excited to have all of the viewers here joining us today. This is going to be wonderful.
I know.
Yay.
This is awesome. And make sure you're commenting, you're interacting with us. We can't be in person for this type of event this year, but I would love to hear what you guys are thinking, or if you missed something, if your internet skips out, let me know and I can repeat something. So we have some questions that we got on Instagram and we got on Facebook. So I'm going to start going through those questions and answering them. And like I said, just keep commenting on Facebook, commenting on our live if you have any more questions.
I'll let them know. I'll keep an eye on the stream, and I can let you know, Amanda, when we have a question come in. So
Perfect. Awesome. So one of the questions that we got was, how do we know Uranus is on its side? So, the Earth is, I meant to grab a ball to show you guys with. So we know that, I thought I have it on the table here. Oh, perfect. So, oh yeah, let me grab it real quick. Thank you. I had all my materials together, but I have a cat. I think he must have stolen it. So we know that Uranus has the largest tilt of any planet in our solar system. And the person that was asking us on Instagram, she was saying, how do we know that the other planets just aren't tilted? Like, why is Uranus the one that's tilted? How are the other ones not tilted? So one way we can explain that is, well, if there are a lot of things that are one way and there's one that's not, that would be the anomaly. And so that's why we say Uranus is tilted on its side, not all the other planets. But like I said, Uranus has the largest tilt of any planet in our solar system. So we know the Earth is at a tilt. So if something was straight up and down, it would be like this. And, Earth is on an axis, and Earth is actually tilted just a little bit. Something that a lot of people are surprised by is that when we have really big earthquakes here on Earth, it can actually mess with the tilt a little bit, like a couple decimals of a degree, but it can actually, Earth's tilt is not always the same. It can actually be impacted by earthquakes. Like there was one in Chile a few years ago that tilted it a lot. And so Earth is tilted a little bit, but Uranus, instead of being tilted like this, is actually sideways, and it spins like this. And, if we're looking at like this way, it would spin like that. While normal planets are just going to be spinning like this on their axis. So that's why it actually spins on its side, which is super cool. And the rings of Uranus are sideways compared to the other planets. So like I said, when Uranus, since it's tilted sideways, the rings are going like this instead of like this, like the rings on Jupiter. So that's what we know about Uranus. And that was a super good question. So for those of you who are just joining us, we're talking about Uranus, and we're talking about questions that people had about space, and so many people reached out to us on social media for this program, so I was excited about that. All right, so Jacob has a question for us, and we will get to our Facebook questions here in a little bit. We had a question about photographing space with your cell phone. So I was talking to Lisa. I think this would be such a cool program to do on its own, because this is such a cool topic. Did you know that you can take pictures of space with your cell phone, and some of them can actually turn out really good? So I'm not going to go too in depth about this today, but I did get this little chart from this website. If you guys, we can post this link later. This has some awesome things to download and talk about for taking pictures of space. So one way to do space photography or astrophotography, if you want to sound super cool, is to download a long exposure app. Now, newer iPhones and newer Android stuff like that, those have settings where you can do exposures, and all on the website that's at the bottom of this slide, there's a chart on this website that you can download that'll actually tell you the exposure times for space photography, and depending on what you want to do with that. So there's different things that you can target when you're doing space stuff. And something that is recommended is using a camera tripod to hold your phone, or just keeping your phone in the same place. So if I'm doing astrophotography and I'm using a long exposure lens, I don't want my phone to be moving each time that I'm, using my long exposure. Then my pictures are going to come out super wonky. That's a scientific term, guys. Wonky. So you want to use a camera tripod if you're going to be doing long exposure. Now, depending on what your target is, your celestial target, it may be the constellations, moon, or star trails. That's going to change your settings on your chart here. And like I said, this link at the bottom, it has some awesome resources for astrophotography. And it talks about how to set your settings and what to do and what type of lens you want. So like Amazon has a bunch of lenses, like angled lenses that you can buy as well for pretty cheap. Like I've gotten some for like $2 before, and you can order those and you can just experiment with it, because that's what science is. If we go off of the same thing, the same procedure, the same thing every time, we're not going to get any better at science. Like, who knows, you might find something super awesome that no one has seen before, or that no one has photographed in that way. So That's why I say just play with it. That's, that's science. Just play with it, figure it out. So I think that we should do another program about photographing with your cell phone later. I think that would be awesome.
Yeah.
And so I'm not going to go.
Go ahead and like and comment. Say if that would be something that would interest you. I know for me, I was telling Amanda, I would love that. Yeah.
Yes. And that's just, I was like, that's not something I can do in like 2 minutes per question, but I think that's so cool. And a lot of people don't realize you can take pictures like that with your phone. Like if you Google cell phone astrophotography, the pictures will blow your mind. It's out of this world, literally.
Excellent. Did you get the question from Jacob? Amanda, how many rovers have you ever sent out in space?
Yes, so let me go grab a picture that I can show y'all before I go on to this next question. I'll be right back.
Very good. Thank you all again for joining. There are so many people out there. Thank you all for joining us tonight. This is great.
Yay. I know this is great. I've got this really cool poster that has all of the missions that are going on right now and the past missions from NASA. So let's see if y'all can see this. Every little speck or all the words that you see on this, I'll show this part first. These are all the different satellites and things that we have in space right now. So I don't know if y'all can see that.
You hold the bottom here. To the camera, but yeah, it's pretty.
Yeah.
Pretty amazing.
Yeah, I've got my background thing on. Let's see. Oh, there we go.
I can see a lot of specs. That's amazing.
Yeah, so we have a lot that are out. So we have, we have all the Artemis missions. We have all kinds. And then this one's really cool. I'm going to send a copy of this to the library for Miss Lisa, and then I'm going to send one to John. This one's actually color-coded based on what the mission is for. So if it's like a biology mission or a heliophysics mission or a planetary science mission, that's all color-coded in this cool little poster thing. And maybe we can we post a picture of this on the Facebook page afterwards?
Absolutely.
So y'all can see? Okay, cool. I'll take one and send it to you. Yeah, so Jacob, we have a ton of missions, and off the top of my head, I don't know an exact number. But right now, the hot topic in NASA right now is the Mars 2020 Perseverance mission. And I'm going to go into a little bit of detail about that here in a few minutes. So another question that we got on the internets, on the interwebs from Instagram is, when is the next big meteor shower? So you can always see shooting stars. And you can see those any night that you go out and the sky's clear. But the next really big, good meteor shower is going to peak on August 11th and 12th of 2021. And the moon will be 13% full, so it's not going to be super bright, and you'll be able to see those shooting stars or those meteors really well. And I put another link here, and we can post this one as well. Earth Sky has some awesome interactive stuff on their website, and you can actually look at calendars of what's going to happen in space. NASA also has a really good calendar on their website about what's happening in space, like today, tomorrow, this month, what to look for, stuff like that. All right, and another great question from Instagram. This one was from Anna. She said, what is the Bethlehem star I heard so much about? So if you went outside in mid-December this year, you probably saw a really, really bright star. And that bright star is the alignment of two planets, Saturn and Jupiter. So a lot of nights we can go out and look into the night sky, and we can see Saturn and Jupiter. We can see Mars. We can see Venus, because they're our planetary neighbors, kind of. And we can see those. But during December of this year, they actually aligned. So it's like if I had two flashlights that were just orbs of light and I aligned them, it gets so much brighter. And I read some really cool commentary about this. And there was someone on a forum, they said, what is this going to look like? And that person, the scientist that was talking on the forum, he said, well, no one on Earth has been around to experience this phenomena. So we had no idea what this was going to look like until it actually happened here in December. So if you heard about the Bethlehem star in December of 2020, what they were talking about is the alignment of Saturn and Jupiter to make one really big, bright star.
Amanda,
So
question from the live stream here. This is from Jean. Saturn is my favorite planet. How many rings? What causes them? And are there colors in the rings?
all right, so that's one of my favorite questions. So a lot of people think that the rings of Saturn are just like a CD, and that it's just like one flat piece. And that's not actually true. The rings of Saturn are actually made of giant blocks of ice, and I call it space junk. And they're made of those things, and it's just moving around the center of the planet in that thing that looks like a ring. And so when we take pictures of space, we often use different colored lenses. So we're using like maybe a red lens to kind of offset the colors and this other light, I say light pollution that we're getting, from the atmosphere, stuff like that. So off the top of my head, I'm not sure what the exact color of the rings would be, but based on their elemental composition, so like what elements are there and like the ice stuff, I would say like grays and browns. But I am not sure off the top of my head. I will definitely look that up for you.
John, do you have anything that you know about with this?
Yeah, do you know?
I'm not sure it has I'm not sure if it's official color either, but it's interesting to think. You asked how many rings there are, and yes, it's true that they are broken up into sections, but the gaps in between those rings, or the CD pattern of ice and dust particles, are actually caused by little moons, little shepherd moons that actually kind of clear out a path, kind of gobble up like a vacuum cleaner going around the orbit of Saturn. They kind of clean up the path on their way. So the separation between the pluralized rings is actually caused by orbiting satellites or moons around Saturn, as they just kind of sweep up the dust particles in their path.
Right. Something I like to talk to people about. It's like if you've ever been like a fog machine and you kind of move your finger through that fog machine, it clears that little area where your finger just was, and that's kind of how it separates into the rings like that. So that's if you're talking about the number of rings, that's probably what it separates out because there's stuff moving through it and it's clearing that space. So that was a really good question. Yeah.
That's great. That's so cool. Gosh.
Right. So now I'm going to talk a little bit about the Mars 2020 mission because, it's so awesome. So I showed y'all this poster earlier. Here is our Mars 2020 mission poster my cool background. I have to have it. I have it for all my Zoom meetings. And that background is, it's Meteor crater, and it's in Arizona. And I actually got to go there. And I saw something the other day. If I move to the side a little bit, there is the visitor center there. Can y'all see the building there?
Yeah.
I'm pointing to it like it's going to help y'all. So like right here is the visitor center. And I saw a meme on Facebook the other day. It said, wow, look how close that meteor hit to the visitor center. They're so lucky.
John, we went there. John and I, just full disclosure, our brother and sister here. John, we went there, didn't we? Because we have family in Arizona. I remember you stand on the edge of that thing, and it's
huge. Massive.
Huge.
Oh,
yes.
Yeah.
It's one of the most well-preserved craters that we have here on Earth. So that's what's special about my background picture. So it's cool.
Great. I thought
so
Mars, honestly, it looks like another planet.
Yeah, that's actually Earth. That's the deserts that we have here in the U.S. I did not understand the majesty of the desert until I went out there, and that's all you see for like 6 hours.
Beautiful.
So let's talk a little bit about Mars 2020, and then we're going to kind of get into our presentation. So the key objectives of the Mars 2020 mission is to explore a geologically diverse landing site. And that geologically diverse landing site is called Jezero Crater. And Jezero Crater is super cool because there's this thing, and scientists haven't named it officially yet. We kind of have some ideas about what caused it, but that's why we're sending the rover there. And what it looks like is, remember how I said we can apply Earth geology to other planets? It looks like it was formed by moving water, and it looks kind of like a canyon. And we don't know what caused it because there's no liquid water on Mars, right? But it had to have been caused by something. So we're going to explore this geologically diverse landing site. And while we're doing that, we want to assess ancient habitability. And so was it possible that things lived here at one point? And we're going to be collecting samples, analyzing things, doing all the cool science stuff. Another thing we're going to do is we're going to seek signs of ancient life. We're going to particularly look in special rocks known to preserve signs of life over time. So we're going to be looking at the fossil record if we can find something, or we're going to be looking at something called stratigraphy, so the rock layers. And if liquid water did run through there, that's going to be an awesome way for us to look at the rock layers in that valley type thing. We're also going to gather rock and soil samples that can be returned to Earth by a future NASA mission. So this Mars rover is super cool. Here's a better picture, maybe.
There we go.
There we go, right here. It actually comes equipped, I say it comes equipped. They designed it to have these tubes that collect samples, and it's going to package these samples, and then that way when we send, another mission later on, we can just collect those samples. And we're also going to demonstrate technology for future robotic and human exploration. So that's the goal, is to get humans not just on the moon, but on Mars as well. So we know that it already launched. We launched it from Cape Canaveral in Florida, and it's going to hopefully spend about 2 Earth years on Mars, and it's going to be exploring that Jezero crater landing location. And NASA's website has some awesome pictures of Jezero crater, and you can see where volcanoes have erupted and impact sites. It's so cool. You can look at those pictures on the NASA website. I just love looking at the NASA photo galleries because there's so many pictures, and you look at things like on the NASA calendar, you look at them and you're like, is that even space? Like, let me see one of the prettier ones.
It is pretty amazing. Brittany, Amanda, whenever you do get a chance, this is related to what you're talking about with the rover. Brittany posted,
yes,
with talking to a rover or moving it, are you moving the joystick and then waiting 20 minutes? What's the delay to Mars? Or is that just in the movie The Martian?
Right. So yes, there is a very long lag time. I think it is about 6 minutes now. So we moved the Mars rover, and like it's not just a joystick. Like there's multiple things that are being controlled at once, and you have to wait about 6 minutes for it to get to the rover, and then the rover moves and then sends the notification back that it actually moved. So it's a very long process, and you know, it's crazy because you're like, you know, what's happening in those 6 minutes? Like, did we get stuck? And you don't know. So there's like 12 minutes where you're waiting, and you have to just fingers crossed, like, did it do it? And there was, I read one time that the Mars rover wasn't working and it was stuck or something, and they programmed it to hit itself to see if that worked, to get the part unstuck, and it actually worked. So when all else fails,
they did a Fonz move.
Yep. Yep.
Percussive engineering, just jump.
That's the technical term. Yeah.
Yes, percussive engineering. I love that. That's great. Now, I'm going to go into a little bit of the hardware that the Mars rover has on it, the Perseverance rover. So one of the things it has is the Mastcam Z, which is an advanced camera system with panoramic and stereoscopic imaging capability, and it can zoom. So we haven't had a lot of rovers that have the ability to zoom in on things. So we're like, ooh, fossil, zoom. We can actually look at it closer now. It also has a super cam, which can provide imaging and chemical composition analysis. Now, why is that important if we're looking for fossils or ancient life on Mars? We can actually tell that this chemical signature is possible, like life needs that chemical signature, and we can actually look for that. We also have X-ray lithochemistry, which is an X-ray fluorescence spectrometer with a high-resolution imager, and it helps us map the fine-scale elemental composition of the Martian surface materials. So we have a scanner do thingy-majig that helps us look at the things on the surface of Mars, and it looks at the composition of the rocks that are going to be on the surface, basically. We also have a scanner that can look at potentially habitable environments. So that's super cool. And I like to joke, NASA has a lot of acronyms. So as I'm making sure I'm going through all this list and getting through all of them, there's one called the RIMFAX, which is the Radar Imager for Mars Subsurface Experiment. And that's a ground penetrating radar. So it can actually scan below the surface of Mars where the rover can't get to, but we can at least see what's down there. So does anybody in the Facebook Live, do y'all want to take a guess of about how much the Mars Perseverance rover weighs? Like within 50 pounds. I know there's a little bit of a lag, so we'll see. Anybody wants to take a guess within 50 pounds of about how much Perseverance weighs?
Guessing you'd want to keep it light because it's something you send up in space.
Right. So something I tell a lot of people is space is expensive. And every little thing that we have to carry up there is more fuel that we have to spend money on.
Yeah.
So anybody on Facebook want to take a guess of how much the Mars Perseverance rover weighs? Play the Jeopardy theme music here. Do, 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 do. Okay, so we have one guess at 1,000 pounds. It is actually more than that. So it is more than 1,000 pounds. Brittany says 435 pounds. Not quite, but Perseverance is 278 pounds heavier than the Curiosity rover. So Frank says 400 pounds. So it is more than 1,000 pounds, if you want to keep guessing. So Ann Carol Mayo says 38 pounds. So it weighs more than 1,000 pounds.
250. Higher, guys, higher. Guess higher.
I know there's a lag, so I don't know how much the lag is.
I love it. It's great, though. I think it's interesting. A couple said around 400. It's very interesting. Higher than 1,000 pounds.
Yes, way higher than 1,000 pounds.
1,500.
1,500. Okay, we're getting there, but keep going.
Keep going. Keep up.
Yep, keep going up. It's more than 1,000. It is more than 1,800. 2,200. Ooh, that is almost within 50. 2,200 is almost within 50. Y'all are doing awesome.
I feel like I should do the auctioneer's voice. 2,200. We gotta go.
Yep. So y'all are getting some awesome guesses in.
I love
but
it.
Perseverance weighs 2,260 pounds or 1,025 kilograms. So it's big. It's about the size of a small car. The dimensions of it are about 10 feet long, not including its little arm, and 9 feet wide and 7 feet tall. So it's about the size of a car. So that's how much Perseverance weighs. All right. So now let's get into the beef of our actual lesson. Now we're going to talk about aerodynamics, which is that really big, scary word. Well, it's not that scary, guys. It's actually pretty cool. So the dictionary, or the textbook that I looked at, says that aerodynamics is the study of the properties of moving air and the interaction between air and the solid bodies moving through that. So let's think about that. We all might not have as much experience flying, but we have a lot of experience in the water, right? I know we have some people that are actually watching our program from the lake, right? Jacob and Liam. So they probably spent the time on the boat today. And when you swim, you're pushing the water out of the way. And that's what's happening when things are flying as well. Now, if y'all want to interact with us in the comments again, why would aerodynamics, or how air moves around solid bodies, be important to NASA and space science? I know there's like a 15-second lag, so I'm watching myself talk with my hands on the Facebook Live.
I love this, though. You guys are having a good time out there.
Yes. So why would aerodynamics be important to NASA? It's what we're waiting on answers for.
And in space.
Is it just taking off and landing? No, it is so much more than that, because we have to maneuver the space shuttle, the rover, whatever is traveling through space, and we have to take into consideration all the things that are happening. So we have, yes, it is very, very, very important during takeoff and landing, but it's important all the time that we have things that are in the air. So yes, Brittany, yes, it's very important during takeoff and landing, but it's important all the time when we are launching space shuttles and when anything we're doing in space. And John, if you want to add anything onto my definition, or if you want to explain it a better way, I'm a geologist. I got the rocks.
No, I think that's about perfect, because in physics, we find very little differentiation, in fact, between air and moving through water. Yes, one is a gas, one is a liquid, but the whole scope of it is under one umbrella term of fluid aerodynamics. So moving through
Yes.
air is very synonymous with moving through water. So just like swimming, you can the same rules of physics apply to both. I think that's a good way to put it.
Right. And somebody says it's important to NASA because of how it breaks through the atmosphere. Yes, and that's super cool because the density, or like how closely packed the matter is together, it actually changes when we go from like the atmosphere to space. So that changes a lot. So learning about the aerodynamics and properties of different fluids or different gases is also important. So that's a very good addition to our question there, Jacob. And I had to put this meme in here because I see it on the internet all the time. I see it in all my space groups. It's the aerodynamics of a lobster. And a lot of times, the warmer colors will mean more resistance, and the cooler colors will mean less resistance. So now that y'all kind of know what aerodynamics is, this is the aerodynamics of a lobster. I had to put it in here because it's fun. All right, now when we're flying, like, so after we have launched our shuttle or our rover or whatever we're putting in Earth, our orbit, or out of Earth, our orbiter, there are 4 forces that we have to do with flight. And those are lift, weight, thrust, and drag. And together, these 4 forces make objects move up or down, and it helps them travel faster or slower. And they all kind of work together, but opposite at the same time, because we need them all to make things fly. It's just like you have to have the water before you can move, and you have to have that acting against you so you can move forward. Now, I've got us a video to watch that it shows us what's going on.
While it's loading, Amanda, I don't know if you saw Brittany's comment, but she said, space is a vacuum. Can't you ignore a lot of physics? John says
Yes,
no.
you can ignore a lot. You can ignore some. I don't know. Did you say the video was loading?
I'm not seeing it yet. I wonder if, could you send it to me? I can pull it up and then share it on here.
Here we go. Let's see.
Oh, maybe.
Is this better?
There it is.
Yeah, I see it.
Okay. So for those of us that are on Facebook Live, we're working through Zoom because this is how we do things now. I've got a video because this video is just super simple, super to the point, and it shows us about the forces of flight, and it'll show you how those forces are acting against each other, but also together. So can y'all still hear me talking?
Yeah.
Okay. So first off, we have our little guy that's building his plane, and he gave himself a push off, but he goes straight down. And that's not good. That's not what we want, because that's all weight. So we have to add something. We have to add wings. I wish it was that easy to build a plane. I would have one in my backyard. So we're adding those wings, and that's going to give us another force. That's going to lift us up. But drag is going to pull us back. So see how those forces are kind of like acting opposite, but we need them? Now we're going to finish building our plane. We're going to get better. And we're going to add something that's going to give us a little bit of thrust. All right. So that's what happens when we have all those forces working together. So can y'all see my PowerPoint again?
I see YouTube.
Ooh, let's see. Like screen share.
No, it's us. Hey, guys.
Hi, guys.
There we go.
I did my makeup for you guys. There we go. So we're back on our PowerPoint. Now, did y'all see in the video how those 4 forces were working together? And how we needed all 4 of those forces, the lift, the weight, the thrust, and the drag. And we needed all 4 of those to make the object move through the air. And in that case, it was a plane. So that is the basics of rocket science. So when somebody says, well, it's not rocket science, this is what rocket science is, this is what they're talking about. There's a lot more that goes in with it, but that is the basics of rocket science. That's the basics of flight. That's what makes airplanes move. And this is basically like what makes you move through water as well. Now, here's another model. This is similar to the lobster that I showed you guys earlier. I used the lobster because it had the key on the side for the, which forces were stronger. So this is just a cool picture. It shows you where a lot of the forces on the space shuttle are and like where the air is flowing. All right, so now the activity of our presentation tonight, I'm so excited to do with you guys. We're gonna do paper space shuttle origami. And I experimented today. I was trying to figure out how I could show my hands folding this thing, but I couldn't find a good way to do it. So I found a super easy YouTube video for you guys. And we're gonna fold the paper space shuttle origami together. So I'm gonna show the YouTube video on my screen again. And before I start showing it, I'm gonna give everybody a few minutes to go get a piece of white printer paper. And if you have origami paper, that's super awesome too. So if you already have your paper, go ahead and leave us a comment in the live. That way I can kind of know when to start.
And this video will be up on our Facebook page at Johnson City Public Library. So if you can't join us now, you're welcome to watch it later and join. Yeah.
Yes.
Great questions, you all. Thank you all for.
I know, this is so much fun.
Yeah. And Amanda, wonderful job answering. Yeah.
Thank you. I'm just glad to interact with people again, man.
I miss this. I miss this so much.
So if you already have your piece of paper, go ahead and fold it over like this if you know how to make a square. So I folded it over till I'm at the edge, and then I have this little flap here. And I'm just gonna fold that and trim it off with scissors or tear it. And that'll give me a square. And that'll get us set up for this YouTube video. So, okay, Linda Stotts Holbrook has her paper. Awesome, awesome. So we're making our paper into a square. And if you have origami paper, that's super awesome. It's nice because you can see, you can like tell which side it's flipped when you're doing it. And that way you can see which color needs to be where. So I've got what's going to be my square. I just got lipstick on my square. There we go. So here's my square printer paper. And usually when you're folding something for the first time, the bigger the paper, the better. So if you have a piece of printer paper, that's awesome. All right, so I'm going to go ahead and hit play because we have 8 minutes left for our presentation. This has flown by like we didn't have enough drag for this. We had too much thrust.
Well, clearly, we need to keep going with this and do some other events. Y'all keep commenting.
For sure.
Things you're interested in, topics that you'd like to watch, you'd like to hear Amanda and John talk about. Let's keep it going.
Yes. So we get the
we have Peyton. Hi, Peyton.
Oh, did Peyton join us?
She did.
Yay!
I love it.
Let me get my screen shared for the right screen.
So great seeing all of you. This is our first program in the new year.
That's awesome. Okay.
What a drag.
Can y'all see my YouTube screen?
I can.
I can.
Yay. Okay, perfect.
Aerodynamic puns.
Yay. All right, so we've got our square sheet of printer paper down, and y'all can kind of see me in the top corner there. Let me see if I can make myself bigger. Can I pin myself? This way I can show y'all. There we go. Y'all can see me. I can.
Did it work?
Yeah, so I can. Yes, there we go. Perfect. So we've got our square. And I'm going to pause it every couple seconds or so, so we can see what we're doing. So we're going to fold it into a triangle like this. And I know that our Facebook Live is about 15 seconds behind us, so I'm watching the live out of the corner of my eye so I don't get too ahead of everyone. Right, there we go. So we've got our triangle like this, and we're gonna crease it. And anytime you're folding origami, I like to use my nail and crease it. And what we're gonna do next is we're gonna make another triangle. We're gonna fold another triangle. So we're gonna fold a triangle, fold it in half, and then we're gonna fold that in half again. And I'm gonna pause it. And when you're folding origami from videos like this, you want to try to maintain the same orientation of the paper as the video. And that just helps you keep your origami the same as the video. All right, we're caught up on the Facebook. So we opened it back up, and we are going to fold the corner up like this. So we're folding the two corners up. And I'll pause it again here. And remember, when we're folding origami, we want to keep our creases super neat. Now, John, I have a super dumb question that has been bugging me this entire time. Is the Hands-On Science Center the same as the Gray Fossil Site Museum?
It is, yeah. We're at the same location, same building.
Okay. Okay.
An awesome place to visit. If you're ever in the area, drop by. I'm always here.
I have actually been by. I met Dr. Widga there.
Yeah. Oh, Chris is awesome.
Yes.
He's so cool.
Yes, they're on my list for graduate schools to go there. I have two schools that I love equally, and I'm waiting on the money. So with graduate school, you don't pay to go. In science, they pay you to go. So I'm in the rigmarole of that right now. So they are tied for my top right now. So yes, I love that place.
You here. It would be so cool.
I know. So I was like, I know I've seen that before. Me and my mom have been, and I absolutely love it. I'm not a megafauna person, so I'm not a big fossil person. I like paleoentomology. So fossil bugs is my research interest.
That's awesome. Very cool.
All right, so we are paused right here. And like I said, make sure you're keeping the same orientation for your paper as the video, and that'll just help you keep up with the origami. So I'm going to start it again after we got sidetracked. And we folded both of our corners up. And now we're going to fold them out a little bit. So I'm going to fold that or pause that a second so everybody can kind of get caught up with what we're doing. And something I like to tell people with origami is that it's very symmetrical. And if you do something on one side, you're probably 99% of the time going to do the exact same thing on the other side. So you should have Baby Yoda so far.
Love it.
So I'm going to pause that. Now, does anyone on Facebook, do y'all want me to go back 10 seconds so y'all can see that part again, or are y'all good? And we're just on the Facebook Live, we're just doing this part. Are y'all good on this part on the Facebook? Should I go back?
And you all need to, once you guys build these, share your pictures through social media. Just at Johnson City Public Library, share them. I'd love to see them. Sure, Amanda.
Yes, maybe we can reserve. Can we save all the pictures, post them, and people can vote on their favorite. Maybe people can decorate it.
I love that. That would be so cool. Yeah, I'm sure we can.
Because we can do a sticker for the winner, the most votes on Instagram or something. I think that's good. Let's do that. So best designed rocket ship gets a sticker from the Mars mission. And at the end, I'll run and grab one and show y'all what they look like. I was telling them earlier, I have all my NASA stuff in a box in the corner, so I have to like go unstack to get to my sticker box. So let's keep going. Jacob says he's doing good.
Good here, says Brittany.
Right, so
yeah.
Yeah, so now we're gonna fold our future rocket in half, and we'll have something that looks like this. All right, so and remember, keep orienting your origami so it matches the video, and it'll make your life a ton easier. All right, and now we're gonna fold that top part down a little bit. And remember, keep your creases, use your fingernail. If you don't have long fingernails, you can use, like they make bone folders. Ask your parents for permission before getting into their craft supplies. You can also just use like a debit card or something like that to make your creases. Just tighten that down and make it neater. Ooh, Brittany says it's on. She likes stickers. All right, so keep it oriented with the video. And let's see what we do next. We're gonna fold our wing up. So it'll be about the halfway point on your sheet of paper. And remember with origami, 99% of the time, it's going to be symmetrical, but this time it's not because it's a little bit different. So I was running my mouth. I'm gonna go back a few seconds because that was a kind of different fold. So we folded that up. And I'm gonna keep my paper oriented with our video. And we open it up. So we're making a crease with that one. And now we're gonna open it back up. So I'm gonna replay that one more time because sometimes that gets a little tricky. So we folded the wing up like this. Or it looks like a little wing. And now we're just gonna open our whole thing back up. Now, when he grabs it, I'm gonna show y'all what to. So see how he's kind of moving that in, and I'll show y'all close up here. He's taking this part right here and pushing on it. So watch very closely and I'll do the instant replay like we're doing sports or something. So just watch where he's grabbing. And he's gonna push that center part up. And then he's gonna fold that square down. And then he's gonna close it. You should have something that looks like this now. Now we're gonna work on the nose of our space shuttle. All right, before we get too far into the nose, is there anybody that needs to be caught up, or is there anybody that's struggling a little bit? Are we doing good? I'm checking the Facebook. All right, Jamie said she's good. Jamie is a pro origami folder. Yeah. Took me a couple tries with this video, like stopping it a couple times just to make sure when I was first folding it. All right, I don't see any yelps for help, so I'm gonna keep going. We're working on the nose now. So we're just gonna keep following our video. And now he's kind of spacing the wings out a little bit, opening it. Ooh.
Oh, you
back.
two.
Yep. Let's go back to our link real quick. Gotta love it.
Gotta make that sweet, sweet ad money.
Oh, you know it.
So I think it stopped sharing. So Can y'all see the YouTube video on the Zoom?
Mm-hmm.
I see it. Yeah. Yeah. It's back.
Okay.
It's at the beginning again.
It's back.
There it is.
Yeah. Okay, there we go. Let me play. We're doing the nose. We're going to fold the nose in. And we fold like that. And now we're going to flex our wings a little bit. So they're going to be on the sides. I'm going to get ready to stop it. All right, check that out. So I'm going to fold my wings like he did. And check out, everybody has a really cool rocket ship. I can't wait to decorate mine.
I love it. It's so cool.
It actually worked out really well.
I know, and it's so simple. A lot of them are like more complicated, but this origami was so good. I can't wait to decorate mine and post it to Instagram.
I think I did mine wrong, but that's okay.
It's okay. We're going to post the link and people can watch it and slow it down.
That's right.
And something I recommend to people is if you're having trouble with origami, you can cut a sheet of newspaper into a bigger square because newspaper creases really easily and it's big.
I like it. I think starting with a piece of origami paper would be helpful too. I'm going to give that a try.
Yes, because then you can see the different colors.
Mm-hmm.
Now, does anybody have any last questions for us about anything we talked about tonight? Or I would love to hear you guys's, I sound like I'm from the north here, y'all's requests for future lessons, anything like that. Even if y'all just want like a quick 5-minute lesson, you know, like Amanda explained science, anything like that. Or if you have any questions about geology too, like yes, I am a NASA Solar System ambassador, but I sponsor a Ask a Paleontologist program here in West Tennessee. So I get emails, like crazy emails about paleontology a lot from kids. Some of them are really good questions. I was like, oh, I didn't think about that. Like I had one kid that was so smart. He says, okay, I know we have the scales of ancient animals. And I said, yes. And he said, and we have the color of them. I said, well, yeah, we have the color that they are. He says, how do we know they didn't fade? Like, I don't know. That was a really cool question. So I get questions like that. If you'll have any paleontology, geology questions, I know we would like to do a future video about astrophotography. Mm-hmm. And we can do one more in depth on the Mars Jezero crater for the Mars Perseverance mission, if y'all want to. So I'm looking to see if there's any questions in the Facebooks. But I know we're a little bit behind on the Facebooks.
I think they're all busy finishing up their airplanes. They're on that sticker. They're decorating already.
I know.
Oh, that's great. Yeah. This has been wonderful. Yeah,
I'm so excited.
Yeah, we'll have to share the links and get them all. We'll get them all posted, and yeah, absolutely. But yeah, Amanda, this has been outstanding. I love my little tiny plane.
This is actually a space shuttle.
Space shuttle.
A space shuttle. Yes.
It is.
So it's kind of, you can kind of see it.
Definitely looks just like them, yeah. Now they used to say the space shuttle flew like a brick. I wonder if this flies in the same way or if it has the lift of an airplane.
I know.
Let's find out.
I did. Let me go. I folded a really cool paper airplane. I'll get my sticker while I'm up too. I folded a really cool paper airplane the other day, and because I was experimenting with what model thing that I wanted to fold with y'all, and I found one that flies so hard it bruises.
Oh, wow.
Don't recommend it because my friend threw it at me. So I'm getting in my sticker box now.
I love it. Well, thank you all at home who've been watching and participating, and yeah, definitely send in your images. We'll be getting that sticker to the winner.
Yes. So here's the other one that I folded the other day that flies really well. It's got like a ton of weight here at the front. There's like 8 layers of paper up at the front, so it zooms. It's super cool. And then the sticker that our winner for the space shuttle contest is gonna get is this.
Cool.
This is the Mars 2020 mission.
That's awesome.
Official NASA sticker.
No. That's great.
All right, well,
Yeah.
I am so excited that we got to do this program after months of planning. And I'm just glad to be interacting with people after COVID. So if you want any more programs, anything like that, we'd love to hear it in the comments, or you can email the library or add us on, or add them, somebody on Instagram. We'd love to hear from you. So if that's it, I think that's all we've got for you guys.
I think John might have brought, John, did you bring that little device to share?
I mean, if we've got time. Amanda, you were talking all about lift, and one way that I like to describe lift, especially in reference to an airplane wing, all has to do with an old scientist named Bernoulli. And Bernoulli has a very famous principle that the air moving over top of the wing of an airplane actually moves faster, because an airfoil is actually a little bit, it's not like symmetrical top and bottom. Typically, the top is a little bit more rounded. So air has to actually move faster over top. We can actually demonstrate that this in a little different using toilet paper. And tilt this up a little bit. One of my favorite tools here at the museum. My Bernoulli.
Oh boy.
This is actually a leaf blower. And at the front, I have attached a paint roller. We can actually attach the toilet paper roll right on top. Now, the way it's positioned, it's going to blow this fast-moving air over top of the roll of toilet paper. And it's actually going to give that the Bernoulli's principle and make it move a little bit faster, lower pressure over the top, making this roll of toilet paper. Let's switch back down. Skip back down.
Oh no!
Yeah, it flies. We make toilet paper fly using physics. Just like the air over an airplane wing, it pushes that the toilet paper up and literally off the roll, flying through the air. Physics.
Physics, astronomy.
Toilet paper was so 2020.
I know. I wanted to do that demonstration earlier in the year.
Yeah.
But, you know, it's kind of a little insensitive when nobody else around has toilet paper. So now that we have plenty of toilet paper, I do it all the time.
That's great.
So much
Well,
fun.
that was awesome. Thank you guys so much for joining us tonight.
This was so good. I can't wait for our next program, Amanda. And John, thank you for coming.
Thank you, guys. Thank you, Amanda.
Thank you,
Yes,
comment
thank you guys
section.
so much.
Oh, great questions, great participation. We will be doing this again. Keep watching. Another thing we have coming up, it's a little different direction at the library, is a big program called Own Voices. It is a program meant to promote, highlight books by authors who are from minority groups, marginalized groups, and you know, just making sure all voices in our community are heard. We're going to have great programming coming up for all ages with that. So look forward to all of that, along with more science at some point. So, all right, Amanda, thank you so much. John, thank you so much, and thank you all at home. And yeah,
Thank
look for future space talks. We will definitely be doing this again. You all have a good night. Share your little devices. Woo.
Yep, share them with us on Instagram.
Yes. All right. Good night, everybody.
Bye, guys.
Bye.